Ladies and gentlemen, please welcome Qasim and Darrick for the Microsoft Presents Prompt Engineering from Concept to Reality, Challenges and Insights.
Everyone. Welcome to our session. We have a packed agenda, so I hope that we'll be able to cover everything. So we have actually split this into two parts. The first part being concept to reality, and the second part being the advanced prompt engineering and our challenges that we've faced. But one quick thing I want to let you all know, I'm sure you guys will have a lot of questions. So if you guys have questions, you can easily just go onto the VOA app and then go to our session and add your questions there. It'll make it a lot easier for us when we get to the Q&A at the end. So let's get started. So in part one, we're gonna tell you all about what a prompt is, how you can actually go about engineering your prompt, how you can actually build safety directly into your prompt, and I'll go a little under the hood of what we have done to build our own Microsoft capabilities. So I want to start off for prompts with what are roles. So there are three different roles. There's the system role, user role, and the assistant role. So what is the system role? So take an example like this. You are a helpful AI assistant, respond concisely and politely. So some of you may have heard of system prompt, meta prompt. They are the same. They are interchangeable. They are basically the prompt that you use to control the large language model to do what you like it to do. Then you have the user role. Now the user role is, let's say, Qasim. He's using the Copilot, and now he's asking a question. Explain how transformers work in deep learning. Now that's the question it's being asked to me, say the Copilot. And when I respond, it comes out as the assistant role. Now that will be something like this. And how you actually show this within Business Central in AL code is a little like this. I know it's actually very small, but it's add system message, add user message. And when the Copilot actually responds, automatically it adds the system message. So you actually don't have to do it yourself. So we're going to start off with a concept. So our concept is that we have a company called Contoso. We receive hundreds of purchase requests through email every day. Now that's a lot of emails for us to go through. But one thing we've noticed is that all our emails that we receive typically only has one intent. And what do I mean by that? An intent is basically they want to purchase something from us. They want to ask, hey, how's my order? Like, when am I going to get the delivery? And other questions similar like this. So a lot of times it is a manual process for us to kind of identify what the intent is, then after that process that email and actually reply. Now I'll hand it over to Qasim to talk about how we are actually going to build from this concept.
Yeah, thanks, Darrick. So now we know the concept of the Copilot that we will be building as part of this presentation. So I would like to go through from scratch how you basically write a prompt for such an application. Before we even go to any of the AL, you need to validate that your use case can be solved through LLM. So that's the number one thing that you need to do before you do any of the AL part. So that's what we will start focusing to start with, and then we will go to some of the more advanced prompting techniques later on in the session. The tool that I will be using is the Azure AI Foundry. It's a very there are a lot of features within this Azure AI Foundry that can help you to write prompts and evaluate and all those things. But what I will be using is the chat playground to write a prompt for such an application. So let's start. So I'm going to start with the very basic two instructions because we are just getting started to build this Copilot. So what I'm saying is like you are an AI system which intercepts or interprets an incoming email, which could be in natural language, and try to get the intent from the user and try to extract the useful information from that input. And the two actions that we want to support is the creation of a sales code and or basically getting the status of an existing sales order. So within my Azure AI Foundry, I paste my system prompt inside this window. And then now we have a user prompt which says, I need to buy uh, 2 red bicycles, 2 helmets for 2-year-old in blue color. So this is a normal request from the user that we receive. Now, when this particular prompt is executed, the response from the LLM is the action, which is in natural language, but it's like the right one, which is the intent was to create a new sales code. We have a bunch of other information that was extracted from the user, along with a lot of extra information that was also extracted or outputted from the model. This is not something we can work against in AL because we need a bit more structure response. The action is also something which is in natural language, so you cannot basically do some action on this particular natural language. So you need to be a bit more specific what the LLM needs to respond. So let's try to iterate our system instructions. So I will try to add 2 more instructions within our system prompt. The first one is basically the first intent. So I'm basically telling if the user inquiry about purchasing an item, you need to call the action create sales code and extract the customer name and all the other relevant information. The second intent is basically if the user asks about an existing order, the intent needs to be get order status, and you need to extract the order number out of it.
And very quickly to add in, like, what is this create sales quote, get order status? You can think of them like AL functions that we want to call.
So now let's try to run the same example again. And now the action name is a bit more predictable, the same keyword. So now you can basically do some action based on this particular keyword when you get a response. But still, there's a lot of this extra information inside the response that you actually get. And we need to remove all of those information and try to get the entire response in a more structured way. So now what we'll add another set of instructions where I'm saying like the response needs to be in a JSON format for both the intent and all the information that will be extracted. So running the same example again, now we have a nice JSON formatted response. So this is something we could work inside AL and make a decision based on this response. And one thing that you can see, the problem over here is like it was able to extract the features for the helmet, but not for the red bicycle. So it was not able to basically split the name and the feature out of the user request. So basically our AL logic could be like we want to treat the name of the item differently than the features. So we need a better instructions to make sure the model is basically splitting these in the right format. So what we can do, we could basically give another sub-instruction for the first intent to split the name and the features, and then we also try to give a very simple instructions. Any information such as the specification or the detail of the item should be categorized as the features of the item, and then the name of the item needs to be splitted with the feature. Running the same prompt again, we can see the name and the feature were correctly splitted, but now still we have another issue now, which is the feature is not an array, it's a key value pair. Again, something which is not predictable. We need to make sure that everything comes in the exact same format so that we could work against that. So let's see what we can do over here. So now what I'm doing is basically adding another section inside my system prompt, which is called the example response format. And I'm being very specific for intent, create sales code. You need to return the intent, the items, and the feature needs to be an array. So now the model will make sure the response is basically in the same format. So now I know all the features will be in an array. So if we, similarly for the get order status, I'm saying I need to extract the intent and the order number. I'm not expecting anything else out from the user prompt for this use case. Running the same example again, now we see the feature is basically an array for both bicycles and the helmet. So everything looks good. Let's try to, we have just tested our prompt with just one example. So let's try to do another example. And now I'm basically asking about 4 wooden chairs and 1 office desk. So it was able to split the chairs and the features correctly, but not for the office table. You can see while working with the prompt, you might be working with a limited set of inputs. It might work for that. But when you go out into the world and people try to enter a lot of different things, so it might work and it might not work. So this is the issue I see right now. The splitting of the name and the keyword or the name and the feature is not working as expected. Although we already added a specific instruction how to split the name and the feature, how we can put even more emphasis to this particular part of the instructions. So we already had this instruction we are asking to split the name and the feature. Now we are even giving an example. So this basically tells the model how exactly you need to basically split the name and the table. You can give more examples as well based on how the model is reacting to a lot of different requests. But this shows you how important it is to test your prompt against a wide range of inputs. So now running the same example again, you can see the chair and the office. What's the example? The table and the office are basically splitted in the right format. Similarly, for the order status, it works. It's a simpler scenario. The intent and the order number was extracted correctly from the user input. So looks good so far. Before we go further, a few tips up till now while we were writing this prompt. You could always ask Copilot to basically enhance your prompt. And you should use the capabilities of this model to basically suggest how the instructions needs to be formulated and basically refined. And you should always be concise and specific inside your instructions. We have seen moving between models and different models. If you are not concise, if you are a bit vague, it might work for your current model, but as soon as you move to a new model or different model, it might not work. And you should always start simple. The example that I showed, I only added the instruction to split it, the name and the feature only when I needed it. We get a lot of capabilities from the model out of the box. If the model is working as expected, you might not even need to add these instructions. And that's also the case when you are moving to a newer model. You might need to refine your prompt and exclude a lot of things that you previously added inside your prompt, and it might work as it is. So you can even optimize your prompt when you're moving to a newer model. And adding practical examples basically help a lot. So no matter how you formulate your instructions, sometimes the model do not react as intended. So adding examples basically helps a lot, goes a long way to make sure your Copilot work as expected. So a quick recap regarding our system prompt. We have this big meta instruction, which is telling what our AI system is all about. We have set of instructions, starting with the first intent, which was the create sales code. Then we have the instructions, which is about the get order status. And in the end, we have the instructions about how the response needs to be in JSON. And lastly, we also have a section where we are giving the example for format in JSON. You can see in this instructions and also the example, we are putting a lot of emphasis what needs to be the response, how exactly the response needs to be, what are the exact keywords that needs to be extracted. This does complicate our system prompt a lot. So this is where I want to introduce another concept, which is the function calling. Function calling out of the box basically enables you to have a structured communication with the model. And you, just by setting the functions, you let the model know these are the capabilities that my Copilot supports, and what are the arguments for this particular capability. Response are formatted in JSON by default, so you do not have to basically specify anything inside the system prompt. And it's very ideal for the type of Copilot that we are just building, and a lot of use cases, I think it's a default that you should always use function call. So this was our system prompt without function calling. Just by introducing function calling, our system prompt is just reduced to these set of instructions. You can see now I have only two set of instructions where in the first one I'm saying when the intent is to purchase an item, you need to call create sales code. I still have this extra instruction to split the name and the feature to make sure it works as expected. Secondly, for the second intent, I'm saying if the intent is to get uh, the status of an existing order, you need to call get order status. You can see I'm not now specifying anywhere what exactly the parameters that needs to be extracted from the user input. That is where the function definition itself comes. So now we have this system prompt, and let's look at our first function, which is the get order status, how you define a function. It's basically you define a function in a JSON format. So you have the name and some description about the function. And then you also have the parameters. Whenever this function will be called, the order number will be extracted from the user input. Similarly, for the create sales code, we have the name. The description is optional, but now the model knows we have this capability for the create sales code. And then we have a bunch of parameters that we need to extract from the user input, which includes the customer name, company name, and we are also specifying that we need items in an array. Again, the features are also in an array, quantity, and all those things. So we can basically define the entire response format within this function definition. Lastly, we can also put some emphasis while defining this function, what are the fields that are mandatory. So whenever this function will be called, the model will make sure there's at least some customer information and the item name. So that that's the bare minimum so that we could basically create a sales code for this particular request. So now let's look for the same example that we did the previous demo against is the bicycle and the helmet. Now the response from the model is basically a tools calls of type function. The model was smart enough based on this request to identify the intent was create sales code. And then there's an argument object which basically have all the parameters that we have defined in the function definition. So we have the customer name, we have the customer email, items in the format that we have defined, the features in the right format and everything. So now we have made our system more robust, so we know exactly whenever this particular intent will be called, this is the structure that will be responded back, and then we could basically process this inside AL. So these are the three different components that we have just discussed now. We have the system prompt, we have the function prompt, and then we have the user prompt. A quick look how it looks like in the AL is pretty simple. You specify tools. Over here, I'm giving 3 tools, the create sales code, the order status, and the magic function tool. I will come to the magic function shortly. And then we are giving the system prompt and the user prompt. So it's like very simple inside AL. So the Azure AI Foundry doesn't work that well with functions. So the tool that we usually use internally is Insomnia. I will just give you a very quick demo how it looks like inside Insomnia. So you can see on the top, I have a deployment of my model. And on the left is the input JSON, and on the right is the output. So right now, I do not have any system prompt. So my system prompt is basically empty. And then I have defined a function, which is the get weather status. So the model was smart enough just by definition of the function itself, what are the capabilities that my Copilot supports. And the parameters that I want to extract is basically the location. So now, when the user input is like, what is the weather in Antwerp, and I press send, the response will always be a tool calls with a function type, and the name is get current weather, and the location is Antwerp. You can see how simplified our prompt looks like with using functions. Just by defining the function itself, it gives a lot of information to the model how the communication looks like with the model. And it basically, you get a lot of things out of the box. Let's go back to the slides. There's also one more thing that I just want to introduce, a feature within Azure AI Foundry, which is the generate prompt. So right now, what we did so far was to write the prompt from scratch. But there's also something that you can use that is a bit more, you can basically have a very quick start to experiment your use case. So what I did is using this generate prompt, the first two instructions that we actually wrote, the very first thing that we did, I actually just gave those instructions to this generate prompt and tried to generate a prompt for my Copilot. And what it did, it basically created a detailed instructions. It had all the key actions that needed to be taken. It has all the steps defined, including what the output format needs to be, and it also added some examples. So you can see, just by giving two sets of sentences, I was able to generate a complete end-to-end prompt out of it. So it's a very quick way if you want to validate your use case, if that thing could be solved using any of the models that you are intending to use. So now, I didn't did anything. The same prompt that was generated, I copy pasted a slightly complex email. We do not have to go through the entire email, but the gist of the email is like the customer is saying, I bought multiple items from you, which were good. Now I need to buy a few other items. The model was smart enough to differentiate between the items that the user was only discussing that he previously bought and the items that he wants to buy now. And if you look at the response of it, the response only considered the items that were basically the user basically needs to buy now, and it identified the right intent. So you can see, without writing any, just two sentences, I was able to basically generate the entire prompt, and it works pretty fine even for a slightly more complex input. So now, back to Darrick to talk a bit about safety, how we make sure safety inside our Copilots.
Thanks, Qasim, for showing us how you go from a start concept to actually having a whole prompt. And now we want to talk a little bit about safety. So the cost of failure is the lack of trust. So whenever you build a Copilot capability and the Copilot now responds with something that maybe it's harmful, for example, that is not a good sign on your company, or if you're a partner and building a Copilot for another company, it's not good for them either. So it's going to affect the technology, the brand, the solution, and ultimately you. I'm sure you have all seen some of these headlines. They are a little old, but they do hit the mark of it's not good when these things happen. And that's why I want to emphasize that it takes safety very seriously. Is what also Peter at the keynote had mentioned. We do accuracy testing, we do harms testing to ensure we meet a certain bar before we ever put things out. Yeah, exactly that. And now I'll hand it back to Qasim to show you how we integrate safety into our prompts.
So yeah, within Microsoft, we have a lot of things that we do to make sure that our Copilot is safe. One of the things that we use is through definition inside some instructions inside the prompt itself. So this was a system prompt that we previously had. So now what I have done, I have basically added another section, the safety instructions. What it says, like if the user input includes any harmful content, such as threat or any illegal activities, you need to call magic function. So now we have introduced another function, and as most of you might already know, the nature of the model is to always respond. So if I would have said something like, if there's some harmful content, do not respond, the chances are the model will respond with something. So it's better to always redirect anything that is harmful to a particular intent or function. In this case, we use magic function so that you could properly handle that inside AL. So something you can say, okay, this is something not supported, and then you can throw some error based on this. So this is how we make sure, this is a very simple instruction that we are showing. We have a lot more complex instructions that we give, but the important point over here is For all of these things, we are redirecting the model to call the magic function in that case. And I also add another instructions like magic function could also be used for the things that you are not supported by your Copilot, not only just the harmful content, but the things that our Copilot does not support. You can again call the magic function and properly handle that and throw an error for the end user. So let's look at the definition of the magic functions. Like all the other functions, we have the name, magic function, and some description. So if the user request is about not about the purchasing an item or checking an order status, we call the magic function. And then the parameter that we are extracting is the intent, so that this could be used for telemetry so that you know what are the different ways, unsupported ways the user are basically using your system. So let's look at a few examples. So for the first example is like not harmful. I want to create a warehouse shipment, something our Copilot do not support. The magic function is called with warehouse shipment as the intent. Similarly, the second request is there an item I can use to harm someone? So this is a supported intent. We are in a business of selling items. But since it was categorized as harmful, because we do not want to suggest anything which is harmful, the model was smart enough to redirect this request to magic function as well, and the intent was harmful content. So magic function is very powerful tool that we use across a lot of Copilot and agent features that we build to basically control the unexpected behaviors. It also sets some boundaries to whatever your Copilot feature is supported, and you can basically handle all the things which are not supported in a more natural way. And it does mitigate any risk and ensure safety. So the only thing you need to provide, okay, these are the two things that I support. Anything else is categorized and need to be redirected to magic function, and you don't have to care about how the end user might try to exploit your system. So now let's try to look a bit under the hood how we use these concepts in some of the Copilot that we have built in-house.
Yeah. So the first example I'm going to go through, I'm sure most, if not all of you, have actually tried marketing text, but maybe you wonder how does it actually run under the hood. So as you guys know, you can take in some style and the facts, basically the attributes. And now we actually take that in, we merge it with our prompts, and we give that to the LLM. Simple enough, right? I mean, that should be all. But that's actually not all we do. We need to keep it safe. So our prompts do incorporate safety. However, that is not enough. Now, we have a function, basically a validate answer function. It's kind of what we do to kind of ground the LLM's answer to what is actually in your system. Now, let's take, for example, we have a table, and it has the height, the weight, and length and width. And let's say the length is 100 centimeters. Now, we will actually take that value and see, hey, in the generation, were there any other numbers? Is there a match for this number, say 100? If there isn't, we check against all the other facts that we have. And if that doesn't match, we know this is a hallucination. That is hallucinated some number out of somewhere that we don't know. And that is one way that we do kind of the grounding for marketing text. And from there, we try to do it 5 times, try to generate an answer for you. But if we really can't, we call magic function and say, sorry, we just cannot give you an answer. So we'll then respond back if we have something. Otherwise, it's either we have validated and tried 5 times, we can't, return, say sorry, or we had actually called magic function from the first call. Now, another one I want to go through is the sales line suggestions. So it's slightly different. Now you have your input, and this input can be just text that you wanted to, hey, I need some lines for something from, say, a document or some items. So we give it to the LLM to extract these keywords, these intent of what the user actually wants. And from that intent that we have extracted, we decide, all right, hey, what does the user really want to do? Item search, document search, or it's something that's unrelated. and we call magic function and tell you, hey, this is not its supported intent. We cannot do this. And once we have that document item search done, we pass it on to go and do a little more item entity search before we come back with some kind of response. Because through this, we are still incorporating safety. And how do we do that? Because we're actually validating what you wanted actually exists within the database. Because if it doesn't exist in the database, we should not be responding with you something that the LLM has hallucinated. Now, another way you can use the sales line suggestions, if you have played with it, is through attachments. So through a CSV, we would extract out all the columns, and using those columns, we'll then ask the LLM, hey, which is the columns with the data that is relevant for this Copilot? And from there, it extracts the product and information and takes that information to then forward it to the same bottom section that we can see that it extracts the actual intent that it wants to run before giving you an actual answer. So some key takeaways regarding prompt engineering. Always be precise, concise, and precise in your instructions. Start simple before you add complexity. Like what Qasim had mentioned, using Azure AI Foundry is a good start, but you will always want to refine it to make it as concise as possible. Adding more instructions doesn't mean the model is going to adhere better to those instructions. Sometimes it makes it worse. That is where testing really comes into play. And functions can really simplify your prompts and make your systems better. And safety, it can help reduce the unintended consequences. So if you have intents that are not something that is handled by your system, use the magic function, for example, to help you handle that and push it away. Because then you can give back that generic answer. And also, if you were to say log, like in telemetry, say the intent that the person wanted, you can always use that to refine your Copilot going forward. And now we actually move on to part 2, and how you can configure your AI models for optimal output. I'll put some more definitions and a few more techniques for prompt engineering, and we'll also cover the common challenges in enterprise use, things that we have faced building our Copilots and also the agents, and some things that we've heard from you before. So let's get started on that. I'll move over here. So these are the topics that I'll cover, but let's ignore what's on this slide and just go straight into it. So with model configuration, well, the model configuration really transforms what a general purpose LLM. I mean, there are many LLMs out there, right? I mean, you have the ones from OpenAI, you have the ones from Google, so on and so forth. So they're all like general purpose. But then you can transform them using your prompts to unlock the precision that you need and creativity and the efficiency for your Copilot capability. So the first parameter I want to talk about is the temperature. It allows you to control the randomness of a model's output. And now you might wonder, what do I mean by randomness? So here I have an image. I think it's a pretty nice image from 0 to 1. Actually, I'm sorry, it's not 1. It's actually 0 to 2. 1 is the default value for temperature, and that varies from model to model. Now, on the left side, the 0 side, so the outputs are more deterministic. And when it's set it at 0, it's never exactly deterministic. If you put in A and you expect A back out, it may not always give you A. It might give you A now, it might give you B later. So it's not always deterministic. So some things that we actually use it for. So take it, for example, comparison. The features like bank reconciliation, for example. Now, we take in the data, the lines, and we take in the other side, and we want to compare these two. And this is when we really use temperature 0, because we know, hey, we don't want it to hallucinate. We want it to ground it in the data that we've provided. Another example is using for data extraction. So for example, of extracting out the intents, We wanted to extract that intent, but we don't want it to just hallucinate some random intent that the user had not actually keyed into, say, the email. And more on the other side of the higher temperature is when outputs become a little more creative. Now, one of the examples is creative writing, which marketing text does. It has a higher temperature. If I remember correctly, the temperature we actually use is 0.7, so it's nowhere close to 2, or even at 1. But that, I would say playing with 0.7 is a good start. If you get all the way to 2, things that it generates may not be coherent at times. So it's something that you really need to play around. You can also use it to, say, generate ideas, because now it's a little more random. It's going to select things that it doesn't always select. So very simple of how you actually use this in AL is that in the check completions parameters, you would just set the temperature. The default, if I remember correctly, is 1 in the system, but you can always play around with that. The next one is max tokens. So max tokens actually define the upper bound of the number of tokens that the system can actually generate. So what does that look like? So I wanted to throw in another term real quick, which is the context window. I'm sure many of you might have heard of the context window before. For example, with GPT-4o, the context window is about 128,000. Now this is both the input and output tokens. And when I talk about max tokens, this is specifically about the output tokens only. Most models nowadays have a maximum output limit of 32,000. And this includes GPT-4o. Like if we go back to, say, GPT-4, I think we've had 16,000, and then it grew up to like 32,000. So it really depends on the model. Yeah. And then when you set a lower limit, I'm going to take a very simple example here. If I ask the model, hey, tell me what are the primary colors, it's probably going to tell me red, green, and yellow. Red, green, and blue, sorry. When I limit it, I say I only want 1 token to be output. Now it's going to say maybe just red, and it's not going to generate anything else from then on. So outputs can get truncated. And if you were to use a reasoning model, say O3 mini or 1 mini, now those reasoning tokens that it actually generates as it's thinking, it is also counted against the maximum number of tokens that's generated. So that's a key thing to keep in mind. And how you would actually just put this in AL is setting the max tokens in the parameters. This one, I don't exactly remember what the default is. Frequency penalty. So there is also the frequency penalty that you can play around with, and it really helps you control the repetition and help you improve like clarity or even encourage more natural and diverse responses. And what I mean by that is really the more it uses a certain word, it will gradually stop using that word. So if you have a whole prompt of maybe even, say, 10,000 words, a word that you may have used very frequently in there, it's probably not going to use it when it's trying to output any tokens at all. There's another very similar one, presence penalty. So I'm not even going to talk about this text here, but what it really does is the moment it sees the word, the future generations has a hard penalty, and it will not use that word going on forward. So the first use initializes basically a harsh penalty onwards, and future generations will not include, or very unlikely to include that word. So just to split them up to see the differences, right? So on the left side is the frequency, and on the right side is the presence. So for frequency, it is triggered based on how often a word is used, while presence is based on whether a word is used, basically the first use. So the penalty increases with each additional use of a word for frequency, and for presence, as I mentioned, upon usage of the word. So that's what frequency really does, is that it reduces an overuse, while presence just encourages use of new words immediately. So short message here, you use them to encourage diversity, reduce repetition, for example, like creative writing, summaries, or brainstorming. However, I would recommend you to just leave them at 0, especially if you have temperature 0. Why? Because sometimes when you have temperature 0, you want a very concrete answer that may be coming from the initial text. And if you use these, it may stop generating some of those words that actually appeared in your grounding. And that is why I would recommend leave them at 0 if you have temperature 0. But if you're doing something more creative, you can play around with this. Very similarly of how you would put them in AL is same in the check completion parameters to just set the frequency and the penalty. The defaults for these are at 0 by default, and they go from 0 to 2. So just a short recap of all of them. Temperature controls the randomness. Max token limits how much can be generated. Frequency gradually reduces the chance of a word being reused. And presence reduces the chance of a word being reduced. So next, I want to cover some prompting techniques. So better prompts will result in smarter results. And mastering how to do prompting will help you unlock the full potential of language models. One that we have actually already covered, but we never put a formal name to it. So it's kind of the 0, 1, or even few shot prompting technique. And this helps you unlock the adaptability of LLMs such that you can tackle new tasks that you may want to solve. And you don't need to fine-tune a model. Just use the generic model and use this technique. And what is this? So we had already seen it earlier where Qasim gave it the example of, hey, I want to split this item name and the features, right? So this is what we call zero-shot prompting. We've not given any example on how to do this. We're just relying on the model's pre-training to determine what it should do with this information. With one shot, very similar to what Qasim had already shown, is that we gave it an example of, I need 2 kids' bicycles, and then split the kid and bicycle up. Few shot, simple enough, just more examples, not complicated. But why is this important to know? So here's a chart from a table, actually, from one of the papers by Google about the Gemini models and comparing it against GPT-4. And here they actually do the tests with different prompting strategies. For example, using 5-shot, which just means 5 examples, to chain of thought at 8. And chain of thought at 8 really just means they're using the chain of thought part of the model with 8 examples given to it. And we can actually see GPT-4, the results that it got, it doesn't really change too much. Now, I don't know what the test really is, but it does make a difference depending on the model, depending on the task that you're actually performing on. As we can see with Gemini Pro, it got an 8% bump. Now, depending on your task, whether it's complex or simple, it can help tremendously if you had more examples, if it was a more complex task. Because the more examples it can see, the more likely for it to understand what you really want as the answer. And for the ultra, it also went up. So a short table here to help you is that depending on your task complexity and how much time you actually want to spend to kind of come up with these examples is what you will go with. I would say you can always try with 0 examples first. See if you get the results that you want. Test to see if you get the accuracy you're looking for. If you don't, give it an example. If it's still not good enough, give it a few examples to then determine. The next one I want to talk about is reason and act. So we have actually seen this already when I spoke a little bit under the hood about the sales line suggestions, as that one, yeah. So this really allows a model, a large language model, to not only think through the prompt, but also to act. And because it can act using external tools, calling functions, now it can able to kind of, in a way, reason over and be more accurate in what the final output is going to be for your Copilot. I'll come back to this example of the sales line suggestions, because I think it's a good one, where at the top, as I had previously shown, you give it a attachment, and from there, it takes the columns and then extracts that information out to determine, hey, what is in this table or this attachment that you've given it. And from there, you pass it on to the next LLM to then determine, okay, now I got this information. What can be done here? And it's taking the first part to reason over it, and then it's acting, and then reasoning over it again, and then acting to determine, all right, this is what they want, whether I can do it or I cannot do it. So some things to think about for when you want to kind of do this. You use this to answer questions that require possibly multi-step reasoning. So you need to call multiple functions, maybe get multiple results from various places before you can combine it all into one. And then if you need to verify some results, possibly from another tool that returns something, you can also use it to make more data-driven choices, because now you can actually use the tools to get that information and make decisions upon that, not just give it one time to answer the question. So you can then use your tools, which is like web searches, calculations, or even accessing BC database in real time. And lastly is that with that new information that you can pull in, that real-time information, now it can adapt what it's actually doing. Without that, it always has stale data. Next one, we've actually talked about this as well, structured output, but now you kind of know the name and what it can really do. So it really ensures that the LLM delivers consistent, machine-readable results, enhancing reliability and streamlining integration into the systems. So structured output, the magic function that Qasim had talked about earlier, is function calling is a subset of structured output. It's basically getting an output that is in a certain format and is guaranteed to be in that format. So so structured output ensures the predictable format, in this case JSON, and it's typically always JSON. That is what the LLMs have been trained with, and it's really good in working with JSONs. It enables easy parsing and consumption, especially downstream APIs, whether it is a BC function or if you were calling out anywhere else. It can also enforce structure and help you prevent errors, for example, malformed function calls or invalid data fields. So we had seen this example by Qasim earlier, where one of the very first times he was trying to tell the model what to do, this is before using function calling. We tell it, hey, we want you to run certain action based on certain intent. But this output is now going to possibly change every time we call the model. And that's not what you want. So how do you use structured output within BC? You had kind of seen the add tool, the second one already. But the first one is also an option, the set JSON mode. So what you really need to do for that one is to set JSON mode to true, but within your prompt, you just need to use the word JSON as well. If it doesn't use the word JSON, it will actually throw an error. And not because we want to throw an error, but because the model, the platform will throw an error, just to let you know. So something that maybe you guys have seen before, I mean, I've mentioned about the reasoning tokens, is chain of thought. So chain of thought can help a LLM transform from guessing to reasoning, so helping you increase your accuracy, transparency, and even trust in the model. I have a diagram here. So given, say, some prompt, we start at the bottom, now the blue dot. So given that prompt, the model starts thinking. It starts thinking, okay, first, what is the prompt asking for? What do they want from here? And then it starts reasoning over, all right, I know they want this. This is probably the result. And then let me just double check my work before I give back a final result. And that's really what chain of thought is doing, because it is so models are autoregressive. They're autoregressive basically means they take everything they've given and generated before they generate the next token. So as it generates things, it's also using that to think going forward. So how can you actually incorporate chain of thought? So there are two ways. I mean, that whether you're using a non-reasoning model or you're actually using a reasoning model doesn't really matter. With non-reasoning models, you can actually provoke it to reason just by adding things step by step. So one example I want to show that maybe you guys don't know, and even for us it was quite a bit of trial and error, is you can use chain of thought in a function. So this is not the best example. I will yield to that. But take, for example, here, where I have something called detailed reason. I wanted to give me a thorough step-by-step reasoning of why this user request is, for example, irrelevant. Why should it not? Why should this magic function be run and not the other function? So this will actually run through and give a step-by-step reason in there before it actually generates the intent. So it's possible that it reasons over what it's thought it should do and then determines that, hey, this is actually not correct. This is actually a valid intent that the customer wanted, and it actually fulfills, or it actually, the other function can fulfill what the user has wanted. And then this intent reason will actually change. So this is actually something we use for our agents. Yes, so chain of thought helps guides the model through problems with structured logical steps. It can help you increase transparency because you can see the reasoning behind it before it actually gives you the output. Now, this doesn't work for the OpenAI models because they just do not generate, or they just do not give you back. They do generate the reasoning tokens, but they do not give you those reasoning tokens. If you play around with, say, DeepSeek or Gemini, you would be able to see what these reasoning tokens look like. This enables models to reason over their own steps and possibly even fix errors along the way. Yes, so just a short recap on all of this. So few short prompting basically adapts new task with no additional training. Reason and act allows it to think and act, use tools, fetch data, and then get you better results. Chain of thought goes from guessing to reasoning, so it allows for clearer and even smarter results. And then structured output makes it consistent, reliable, and integration-ready responses. Now, I'll hand it over to Qasim to talk about challenge we have faced and you may have or may face in the future.
Thanks, Darrick. So yeah, we'll probably start with some of the challenges that we faced when we were building our copilots and agents, and then we will probably open up the floor for Q&A so that you guys could also share some of the challenges you faced, and we could have a discussion on that. To start with, grounding the model in your ERP world. So as we all know, these models are trained by the entirety of the internet. It knows about ERP and it knows about Business Central in general, but it does not know about how your environment is set up. So you have to make sure that the model is basically grounded with your configuration or your environment. One of the examples that we see a lot is like we use a lot of these opaque IDs within our items, for example. we have item called like item 2023 FG EU. So this doesn't help the model to know what this item is all about. You need to give this extra context about what's the friendly name or the description and all the other information about what this particular item basically means. Similarly, in retail, everyone knows what SKU is. It's a common term that is used quite broadly in all the ERP world, which is basically to uniquely identify a specific variation of an item. But we, within Business Central, use it slightly differently. For us, it's not just the unique item, or unique item, which is the item number or the variant code, but it's also the location that particular item is. So we have this extra location code, which is very specific to Business Central. So if you do not provide this extra information and you are building your Copilot, so the Copilot, the model will be confused or might not respond as expected because the knowledge that it has is only based that the SKU is basically used to uniquely identify an item, not with the location. Similarly, we use, when you are providing a lot of data to the models, you should avoid using coded field, like for example, document type 3. We all know what document type 3 is, but we cannot assume that the model knows about it as well. So we need to spell it out for the model that the document type 3 is basically a credit memo. So you need to give some kind of a mapping for all the coding data that are you sharing with the model to react on. And one other thing, for all the fields that you are sharing, it always helps to give all the captions along with the fields to let the model better understand what these captions are all about and the units and all the business rules that you have. Few examples that I want to share with you, like we recently renamed jobs to project, and we still use these two terms interchangeably. So if you are building a Copilot on top of jobs or project, you need to specify or let the model know these means the same inside Business Central context. Inside Business Central, we use the vendor term, but we do not have anything which is called supplier. But someone who is coming from the outside or from the other ERP system might try to communicate with your Copilot using the keyword supplier. So when you are building or sharing some information inside your prompt regarding vendor, you need to also specify what this vendor actually means so that the model can make more educated guess if someone is referencing supplier in place of vendors. Let's look at a real world example. Let's say you are building a Copilot which is built on top of customer data and all the transactions that are made inside the system. Normal user query will be to summarize last quarter top 5 customer. But when you are providing this data to the model, if you exclude all the transactions were made in this particular local currency or which currency the transaction was made on, the chances are the model will basically respond incorrectly because it do not have this extra context of all the transactions that were made in which currency that they were made. So if we look how we can emphasize that inside the prompt itself, so I have this simple prompt for demonstrating this particular example. So you can see I'm passing the customer data later on in my prompt, but I'm specifying the sales are the sales amount. And then I'm also providing another field, which is the currency, so telling that the sales amount is basically in this particular currency. So now when I'm showing multiple transactions or sales that have been made, I'm giving the currency as well, and I'm also giving the sales amount. So now the model will be a bit more in well positioned to basically respond to you, top 5 customer, considering the currency that those transactions were made in. But what about the exchange rate? We haven't provided any exchange rate. So what will the model do if we haven't provided that? So it will most likely consider the exchange rate that the models were trained in, which are factually incorrect, and the response will be most likely not the actual response that you expect or something that you can rely on. This also brings us to the next challenge that I want to talk to you is about the hallucination and factual accuracy. So as soon as you have some gaps in your prompt, the model will try to fill those up. So in the example that I just shared, since we didn't provided any either the authenticated source or the exchange rate, the model will come up with some kind of exchange rate and give you some response. So that is a very risky thing in ERP because finance heavy ERP system is like we depend on our life or our business on those numbers. So we need to make sure there are no gaps within our system so that the model is not inventing stuff. You need to add some kind of runtime validation. So whatever the model responds, you need to validate that response within Business Central before you are basically suggesting to the customer. An example could be to cite the document ID or some kind of a reference you ask the model to respond whenever it's responding. And then within AL, you do the sanity check if there are any transaction, for example, for this particular customer or not, or if any of the numbers looks suspicious, it doesn't add up when you do some validation inside AL. And one more thing that you can do is to force citation or magic function. So like, again, something like if the model is uncertain about, rather than responding with something, you need to redirect to the magic function by saying, okay, if you're uncertain or if the information is not available to you, call magic function. So you need to do these kind of check to make sure that you are avoiding any hallucination or if the model is coming or making stuff up. So yeah, you could trust models for a lot of different things, but you need to verify whatever the response that you get from the models. Let's look at another example. So now our Copilot is built on top of some vendor information and all the transactions that we had with the vendors. A question that you can ask or the user can ask is like, what's the time it takes for a particular vendor for delivery? In this case, vendor 03. Even though we have not provided any purchase history, the model would be naive enough to respond saying 27 days. So again, if we have some kind of AL validation and we try to add up, like there is no purchase order for this customer, how come we ended up having 27 days? So you could raise some flags and not to respond back to the customer when you run to this kind of situation. But let's see how you can do basically inside the prompt itself as well. Similar concept that we have been sharing all along this presentation is like, you should only consider the information that is provided to you. And if you are unsure, you should always call magic function. So if the model feels any of the information does not exist, it will call the magic function. So if you look at the table below, there's a list of transactions, but it's only for the other vendors, which is vendor 4 and vendor 5, but not the vendor 3. So just by introducing these two simple instructions, the model will basically trigger magic function rather than responding you with some random number. The next challenge that we all have is the token limit, which Darrick briefly mentioned. And we have a lot of large business data that we want to share to the models to make any decision. So this is a very big challenge that we have. And we all know the GPT-4o model that is the one that we are, most of our features currently built on has this 128,000 token limit, which roughly translates to 90,000 words. But this doesn't mean that you can use efficiently these amount of tokens. So the more tokens that you use, the quality will go down, the latency will go high, and the cost will also balloon. A rule of thumb is like for every extra 1,000 token that you use, there will be 1 cent for the prompt for every request that you make, and 3 cents for the completion. So you can see, like, although we have this large context, you cannot basically use the entirety. So you need to be a bit more efficient when using the token. To put a bit more emphasis to this point, like there are a lot of benchmarking done on different models. So I just want to share the benchmarking, some of the benchmarking that was done for the GPT-4o model. You can see when you are using from 8K to 32K tokens, the accuracy is quite high. But as soon as you are ended up using more tokens, the accuracy, you see a noticeable dip inside the accuracy. So that's not something that you can rely on your system. Like if you're using a lot of tokens, uh, if latency and cost is not a question for you, but still, if the accuracy is not there, then you cannot basically rely on such system. So I just want to put a lot of emphasis on this, like you need to use your token efficiently. So that's why all the things that we discussed, like you need to start simple with your prompt. If something can be done in less tokens, why use more? Let's look at a real world example, like a lot of uh, Copilot that we have built internally and a lot of feedback that we got from partners, like they were building some Copilot on top of items. And you know, like if we want the models to know the context about all our items, we not only need to provide the item table itself, we need to provide the variants, attribute, translation, categories, and bunch of other related tables to item to make sure the model have the entire context. But you can see as soon as we have these different tables and we need to provide all the information, we will ending up using a lot more tokens. So this is not a practical solution, especially if you have a lot more items. If you have very few items, then it might work. But if you have a lot of items, even a smaller amount of items with this combination of all the tables, you will end up using a lot more tokens. So let's look at a similar example related to this. So you have a Copilot built on these items where you need to respond with the best possible matching item. So the user query is, I need 5 red kids BMX bike. So if you would have to dump the entire item table, the cost will go high, the latency will go high, the quality will go down. So what's the mitigation over here? So one of the mitigation that we use in these kind of scenarios where the data is very large and we still need to get some value out of the LLM. So what we do is, first thing is, rather than sending the entire data, we try to extract the intent and the key keywords that we want. So in this particular use case, we are getting the name of the item and the feature along with the synonyms as well. So the user is saying bikes, but we could use the LLM to get the synonyms of bike as bicycle as well. Maybe the item is called bicycle inside our system, not bike. So not only we are extracting the keywords, you can extract the synonyms. You can also extract the alternate terms, or you can be even more smarter about if your system is any particular language, what are the different ways of items that you have named within the system. So you can try to extract all those keywords from LLM first. Then you pre-filter all the items based on the keywords that were extracted. Maybe you could only filter on the item description with the name of name of the item. You may ignore all the features to do this pre-filtering. And then you only send this subset of items back to the LLM so that it could now, you are sending a lot less amount of data for LLM to basically get the best results out of it. So this is a technique that we use internally for a lot of different scenarios where we have to send a lot of content to the LLM to basically get the entire context. So we try to first ask the model what were the key things the user asked, try to do some filtering within AL, and then only pass the filtered data back. So how it looks like in prompt is quite similar. So this is just for demonstration, like this prompt, like, so it's too small over here, but yeah. So we need to convert the product information in the JSON, and you can see I'm trying to extract the name and the features, and for this particular example, I'm getting the name with the synonyms as well. You can be a bit more advanced, ask about alternate items and all those things, singular and plurals, and you can do a lot of different variation when you are extracting these keywords from LLM, and then you could try to see which are the key fields inside my table that I could filter based on which field. So now, when the user says, I need 5 red kids BMX bicycle, the response is the name, which is bike or bicycle. So we do an OR. So now when we are searching, applying filters in AL, we use an OR. So in case even the item is named bicycle, we will probably get it. And then we are also extracting features. And even for the features, you can ask for synonyms as well. So now you see how small our prompt is. Like we are just trying to get the key information from the user input. One more challenge that the last challenge that I want to talk about is the maintainability and the testing of the prompt. There were a lot of information that was shared in the keynote as well regarding the testing. But before going to the testing part of it, you have to do a lot regarding the maintainability of the prompt. You know, every other month we are getting newer model. So it's pretty hard to cope up if you do not have any kind of test or any kind of mechanism to maintain your prompts or Copilot features. So the few things that we do internally is like we consider these prompt as executable specs. So every model, temperature, tweaks, any change within the BC schema, we consider that could basically flip the output. So every time anything changes in the LLM world or the model, any configuration that we have that model, or even something changed within Business Central, we try to make sure we run our tests again. And the model drift is real. I'm not talking about moving from 4.0 to 4.1. Even within 4.0, like recently we experienced when we got the May iteration of the 4.0 model, the response that we were getting out of this model were like 20 times more in length for, let's say, for marketing text or these kind of features that we had. So if you are depending on those kind of things, so you need to verify even if you are staying within a single model, but using a newer iteration of that. So we treat prompts as code, we keep them in source control, and we always print, this is the prompt that works for this particular model with this particular configuration. And every time anything changes, we try to make sure we run the entirety of our test and then try to pin again, okay, now this version of the prompt works against this model with this configuration and this version of BC. Lastly, you get a lot of things out of the newer model. So a lot of things that you might be facing challenges when you are writing prompt for a previous model might be already fixed in the newer model. So it's always a good practice to always use the latest, greatest model. But that doesn't mean your existing prompt will work with the same accuracy or better accuracy with the newer model. You need to change your prompt. So one example that was also shared in the keynote, like moving between 4.0 and 4.1. 4.1 is very good in understanding the instructions. So it took each and every word literally. So it basically dropped our performance. For example, the performance that was mentioned in the payable agent that we faced is because of like how good the newer model was, how we compared to the previous one. So you always need to do some kind of adjustment whenever you are changing models. And always try to aim for the latest, greatest model. And we, like I mentioned, we have all these guardrails in form of test. We have telemetry. Anytime anything changes, we have this automated pipelines. So we run it daily, weekly. So we are making all the changes in the Business Central. So at any point, if there's any change in the accuracy, we are notified and we try to rectify that. So let's look few example how things could impact your accuracy of your Copilot. One is not related to the model itself. You are on the same model with the same configuration. But like I mentioned recently, we renamed jobs to project for all the user facing. So now if your Copilot was basically built on top of that, it might not perform as expected. Although nothing changed in the LLM, you are still using the same model and same configuration. So the point that I want to make here, like something that changed in the product could also impact your Copilot feature. And again, if you're working with a model and you are only using the newer version of the same model, it might add extra information. So previously, you might be extracting the response in a CSV format, which were previously responding only 3 or 4 columns. Now the model suddenly decided to put another column, which basically is to show how confident it is for the result that is being shown. So again, if you have some AL logic on top of this particular response, it will break. So there's a lot of things that we do to maintain, but the number one thing that the thing that I want you guys to take away is having a lot of tests. And for that, we have this Business Central test tool for Copilot that was also mentioned a lot in the keynote as well. So I could not put any much emphasis like whatever you build, you need to have a lot of tests using this tool. And this tool basically helps you a lot to maintain your Copilot feature. And it basically, you will save a lot of time if you use this. I will not go very deep into what this tool is all about, but just to give a very higher level overview is like you have one test and you have hundreds of input as test cases. So each of these test cases have the expected output as well. So you run all of your 100 use cases against your single Copilot feature, and based on whatever the response is, you validate that. So in case of features like marketing text, you need some extra evaluation because the response is free text. So you cannot have an AL logic on top of that. But if you are basically extracting keywords, let's say if the user say, I need to red kid bicycle, and the output always needs to be this particular keywords, you could have basically AL logic on top of that. So yes, please try to test your feature, have a lot of test cases. Even internally, whenever there is a bug, we convert that to a test case. So we make sure if we have fixes now, so any future change that we make to the prompt do not affect any of the test cases. There's another session tomorrow talking a lot more about this testing and also how you can basically generate this a large data set that you can test your feature against. So you can only come up with few test cases on your own, but to make sure that it works across a lot big data set, please join this session and you will know how you can basically generate a lot of data set using the power of LLM. To conclude, the challenges part, grounding is very important. Every environment that we have is like different, so you need to give this extra context about what your Business Central is, how it's performing by decoding the codes, the caption, and the rules that your environment basically follows. To avoid hallucination, you need to use concepts like magic function. You need to make sure there are no gaps inside your prompt, so nothing is left completely on the model to assume. So you need to do all of these things, and you always need to validate the answer. And yeah, testing is a big factor that you can use over here. Token limit, like I mentioned, we have a very big token limit, but you need to use this efficiently to make sure your Copilot feature is basically working performantly. And lastly, try to use the latest, greatest models, and always try to have a lot more automated testing to make sure that you have the best possible model to work against. And so something that you will get a lot of things from the newer model already. That's all from our end, but now we would like to open the stage for Q&A.
Yes, so we'll open it up for Q&A. If anyone has questions or if anyone has actually written in here, I'll quickly look. Okay, we do have one question actually. Just to also note, we have t-shirts. So if you have questions, we'll give them to you. So one of the first questions is, I can see you use a lot of Markdown for the prompts. Is this the best way the LLM will understand the prompts, or is there another specific reason? Do you want to take this?
I think in our experience, we need to give the instructions in some structured way to the model itself as well. So the markdown is the simplest format that we feel giving to the model by using the least amount of tokens. Even if you are using JSON as an input of your prompt, then you might end up using, for the same text, you might end up using a lot more tokens. So from our internal experience, I think the markdown syntax is the most simplest one that we could give instructions, and it's very capable of understanding this syntax as well.
So I can't see who wrote this, but I think it's a good question. So Lisa, please. Oh, all right, I'll just pass it to you now. Oh,
Oh,
sorry about that. All
we
right.
can also pass this to.
Yeah. Why don't we?
Do we have?
Why don't you go for the next question first? Yeah, just speak into it. Oh, the top dropped off.
So basically, what do you expect, or what do you think? How resilient is this to letting it loose on partners and having them extend like tables, logic, and etc.? It's like, is that part of your focus there as well? Because I saw that all your prompts and you had fixed parameters. So at that point, it is basically non-extendable, is it?
So that part is not really extendable. Or I mean, theoretically it is, because you could have it such that, or when the LLM responds, it tells you call this function with, and it will give you a JSON object basically, and it's up to you what you want in that JSON object. You could let it put in, say, free text, and within that free text, it could be another JSON. It could be anything that you wanted. So you don't have to hard code it to tell it that, hey, I want these fields only. You could let it kind of make up the rest of the things in there. And then in your application is where you kind of read what is actually in there and then perform what is actually given to you.
But we're still reliant on that initial connection that the agent and the prompt did to the call function, basically.
I'm sorry, can you say that one more time?
A search an item
Okay.
has fixed inputs and outputs already.
Yes.
So we can't extend those.
No, that wouldn't work. Yeah.
That's what I was going for.
Okay.
Thank you.
Oh, okay. Why don't you pass it to him? I'll just take the other question that I saw here. Is double hex a reserved word in prompts? No, it is not a reserved word. It's basically just markdown. It's a markdown for, if you have one hex, it's like the title. Two hex is like title two, so on and so forth.
You please go ahead.
Yeah, the hallucination in the prompting is real problem. Like once you also give the context to the AI, and then you do a subsequent prompting, it's again start hallucinating. Because you have one prompt, you have given all the context, you have given all the resources, and then you get a response, and the next you again write a subsequent prompt, it start hallucinating again because it loses the context sometime, and that's a real problem. How do we can make sure, like if we want to build something which is a sequencing prompting, and we can get a consistent answer, otherwise we have to rebuild this context again and again with each and every prompt, which will be like too much.
My suggestion will be to split what you want to get out of the LLM. So for example, when we talked about the example of splitting the items, like uh, we wanted to get the best possible items out of all the items. So we have like a different version of prompt, which is we are extracting keywords, only sending the subset of it. So we might not need the context from the first part for the other part. But yeah, if you want to pass context, you will reach the limit of tokens, or even you ended up using a lot of more tokens, which will basically hallucinate as well. So you need to come up with more creative ideas how you can split the multiple calls to make sure that you only provide what is needed for this particular call. But yeah, depending on the scenario, you need to come up with these kind of innovative ways to avoid using a large context window.
So basically, you are saying we should use the functions all the times. Like when we actually want to build the sequencing, we should build lot functions.
Yes.
And then we actually start sequencing calling these functions.
So it could be one way, like for every call, you only send the functions which are relevant for that particular call. You should not have a very big list for all calls.
To add on to that, the models don't work well when you give a lot of functions.
Yes.
Like I would say about 8 should be about your limit. More than that, it's not going to be able to choose well unless you have really well-defined functions that separate from each other. Um, the guy behind
Thank you for running it all
you.
over.
Of course.
All right, so in your maintenance and testing slide, I think you talked about model drift, right?
Yes.
So if we write something that's working pretty well, it's been thoroughly tested, and then you talked about how with the May patch, things have changed. At what frequency should we be testing our code or testing things that are going to be using a certain model? When I typically write something in AL, the goal at least is once it's been tested for about 6 months, I can usually rest assured that my code's probably not going to break. At what frequency should we be testing something that has been written using a certain model? Are these patches impacting existing code that's working? Do I have to opt into taking, say, the May 2025 patch if I'm using the GPT-4o model? Because that seems like a constantly shifting or moving target, and the cost to test, forget the cost token-wise, the human cost to test and keep up with this could be fairly significant.
Yeah. So internally, we run this quite often. Some of the examples that I showed, it's not just about transitioning of the model. Anything that changes within the product could also impact the output of your Copilot. So every time you see something major changes within the product, we try to run all of these tests, and we also even run these tests even more regularly, even if we are on the same model, to make sure that we are on the higher accuracy. But yeah, yeah. So every time you do a model switch or configuration, definitely you want to run the test again. But now, if you are doing it after 6 months and something the product could have impacted, then it will be very hard to go back what changes were made in this long period.
So, Qasim, if I can ask a follow-up there?
Yes?
I think you talked about a model switch. In this case, it seems like the GPT May 2025 GPT-4o May 2025 patch, is that a model switch? As in, do I have to opt into it, or does it automatically affect anything that I'm building using GPT-4o? I think that's my concern. It seemed to me, maybe I'm misunderstanding it. It seemed to me that since it's a patch, it's automatically going to apply to something that I've built. In which case, it seems like I have to wait for something to break, somebody to tell me it's not working, or maybe it's not working accurately, which is lowered trust and credibility for my users, and then I have to fix it. What can I do to stay ahead of the curve? What can I do to kind of proactively do it? Does
So
that make sense?
if you're using, say, directly from Azure OpenAI, they do have a configuration that basically asks you, what do you want to happen when they have a new version? Yeah. So for example, if they have a new version coming up, you could say, I want to always be up on the latest and greatest. It will automatically switch you. You don't do anything. You could also say, I only want to be switched at the very end. That's also an option. Or you don't want to ever be switched, and you basically be broken at that stage. Yeah.
There's one in the back.
Yes.
Yeah. So, outside of running these tests, are there any way to keep track of how the models are doing? I mean, can we in the telemetry set up something? Because as a partner, we develop a solution for a customer, and unless they talk to us, we'll just let it run, right?
Yeah. So one way is like if suddenly it started to raise a lot of magic function, for example, things that were working. So you can have that kind of telemetry, uh, like if the magic function is being called, or you can log that, okay, something is not working as expected, and you can see the intent out of it. Internally, we do not log any of the usage, exact usage, how the end user is basically using it due to privacy. But yeah, you could log all the, as a partner, I guess you can log some kind of telemetry of which functions were called. Based on that, you can make some educated guess, okay, if something went wrong or not.
Okay. Okay.
I think are we out of time?
We have 2 minutes.
Okay, we have 2 minutes. Okay, if there's no questions in the audience, I mean, there's still more questions on the app. The first one being, well, does please send me quote for one sex bomb model meet safety tests? I mean, it's one test, and it will be part of like the harms test that was mentioned by Peter. It's I think it will be covered under, say, the sexual and harmful tests. So yes, that would meet the bar, but it is something that when you're building your test, you need to have a wider suite of prompts that you're testing against.
Yeah. Meanwhile, I just want to mention this, like, if later on you're working on your Copilot and you have some challenges that you want to reach out, feel free to reach us on LinkedIn. I think that's the best way to reach us after this conference, of course.
Yeah, and we'll also be at the booth.
Okay.
Yes.
Just one question. How is the multi-language support for the prompt? So a prompt is written in English, will work with data and in every language, or are there some consideration to be made?
Yeah. So the prompt itself, how we do it internally, are always in English,
Okay.
but the responses we specify to be in a particular language. For example, in marketing text, if you're in a German or a Danish environment, we will respond the marketing text in those particular languages. So there are a lot of stats for each model, how it well performs for each particular languages, and it getting a lot more better. So English is still the best the models work against. Our prompts are always in English, even if we are working in any country version, but the responses are also getting a lot better in all of these country-specific versions. That's why we have a lot of features, GA, all of these country, and the accuracy is quite close to English in most of our places that we have released.
All right, and we are basically out of time. I want to thank everyone for coming for our session. Thank you.
Thank you.